hungry for energy. As our populations grow and progress, our need for energy continues to grow. Fuel for transportation, electricity for homes, power for commerce and industry. Every Australian uses an average of 8 litres of oil every day. Australia is a lucky country, rich in natural resources. It is also fortunate that some of the world's major new oil resources are virtually on its doorstep. In late 1996, the 81,000-tonne concrete gravity substructure, which is the oil storage component of the Wandoo-B production platform, ended a unique 1,700-kilometre journey from Bunbury in the southwest of Australia to the Wandoo oil field on Australia's northwest shelf, 70 kilometres off Dampier. 400,000 barrels of oil will soon be able to be stored in this innovative structure when the platform becomes operational. Now the CGS is awaiting the arrival of the operating decks, which will make the platform complete. In December, the 6,500-tonne topsides, which was assembled in Singapore, set out on its 3,000-kilometre journey.
Manila, the capital of the Philippines, is a city hungry for cost-effective energy. The Philippine government is spending $4.5 billion on the Malampaya deep-water gas-to-power project, the largest infrastructure development and investment ever undertaken in their country. When completed, it will deliver enough gas to generate 2,700 megawatts of electricity, in excess of 30% of Manila's power demand. In September 1998, the Malampaya CGS Alliance, a partnership of John Holland Arab Energy and Van Oord AZZ, was awarded the contract for design, construction and installation of a wet storage concrete gravity structure. The Alliance would deliver a fixed storage vessel for up to 385,000 barrels of product, as well as a supporting foundation structure for the 16,500-tonne topside facilities. The plans for the gas production platform required the construction of a concrete gravity structure, or CGS, and a topsides production and accommodation module. Location for the construction of the CGS was a remote site at Green Beach, Subic Bay in the Philippines Republic. Since no access road existed to the site, all personnel, equipment and materials had to be delivered by sea. Construction of a CGS involves a high reliance on a skilled and experienced labour force. The location of the construction site made this a significant problem. The solution, developed by the Alliance partners, was to train a local workforce. Customised vocational training and skill development sessions were put in place to meet the immediate need, while the valuable long-term benefits of a skilled workforce will be felt in the community for years to come. By mid-March 1999, the construction of the temporary works as well as planning and design of the permanent works was well advanced when the client initiated a change from a wet storage to a dry storage system. This meant a rework of the completed design, as well as a significant increase in the temporary and permanent work scopes, all to be accommodated within the original program. The completed CGS has a plan area of 112 metres by 83 metres. The height of the storage caisson is 16 metres, with an overall height of 56 metres to the top of the shafts. The structure contains 34,000 cubic metres of concrete, 12,000 tonnes of reinforcing steel, 750 tonnes of pre-stress and 1,500 tonnes of mechanical outfitting. The total float-out weight was set to exceed 100,000 tonnes. Progress continued and a significant milestone was achieved in March 2000, where all concrete work was completed. By that time, all four 40-metre high shafts were topped out along with the deck connection corbels, slabs at the top of the shafts, as well as the caisson base, wall and roof slabs. All pre-stressing had also been completed and the fit-out of pipe work was on schedule. All four deck connections for the CGS were installed ready to receive the topside processing facilities. The final mechanical outfitting began in March 2000. 4 risers were attached to the outside of shaft number 2. These risers are designed to reticulate gas and condensate to and from the topside's production module. In preparation for the flooding of the casting basin, a channel was excavated and constructed. Of June, the CGS was slowly manoeuvred into position. Ballasting began and the CGS was submerged and placed on the prepared seabed, in the process meeting a specified installation tolerance of plus or minus 1.5 metres. A rock blanket was placed around it to provide scour protection to the base. The open cells of the CGS were filled with iron ore ballast to ensure that the CGS remains on the seabed when the storage cells are empty. This project was constructed to world's best practice in respect of safety, health, environmental and quality performance.
Around the world who've worked together with us to transform the vision of the Malampaya project into reality. Absolutely fantastic. Wouldn't swap it for anything.
The Malampaya CGS project is true testimony to what can be achieved through innovation, cooperation and planning.